Hi, everybody. I've been fascinated by Mars since building a model of Mars using a styrofoam ball and paper mache when I was in fourth grade for a class project. I think one of the most fascinating questions about Mars is whether or not it ever supported life. In this video, I'll be discussing the Mastcam-Z component of the Perseverance rover, which will play a critical role in the search for life on Mars.
There are so many great questions about Mars. What is the climate like? What is the geology of the red planet? Will humans ever explore Mars? One question that continues to fascinate me is whether or not there was ever life on Mars. Speculation that life might exist on Mars dates to the 1850s. Telescope observations of Mars in the late 1800s fueled the speculation and served as inspiration for H.G. Wells' 1897 book, The War of the Worlds, that told the story of Earth being invaded by aliens from Mars. The Perseverance rover is scheduled to launch in July 2020 and land on Mars in Jezero Crater in February of 2021 to begin its exploration of the red planet, and will later be joined in the search for life by the ESA's Rosalind Franklin, which is scheduled for launch in 2022. Perseverance is equipped with a number of instruments designed to collect data and information about the red planet beyond the capabilities of earlier rovers such as Curiosity, Spirit, and Opportunity. Mastcam-Z will take 3D images and high-def pictures and video to provide critical information to help identify the best path for the rover to follow and to identify locations to take samples which can later be analyzed for biosignatures which, if found, would provide evidence of past life on Mars. We know that the earliest life forms on Earth evolved in water, so it's logical to think that if there ever was life on Mars, that it would have developed in water as well. The Jezero Crater landing site was selected because the crater is the location of an ancient lake on Mars. In the image, the lighter green and yellow colors represent higher elevation areas, while the darker blues represent lower elevations where the lake once existed. The oval shows the landing site, which is near a fan-shaped delta landform created by the deposition of sediment by the river you can see winding its way into the lake in the upper left corner of the image. The second image includes information about the mineral composition of Jezero Crater, which includes the location of carbonates, shown in green. Carbonate fossils preserve information about ancient life on Earth. Many other minerals provide us a great deal of information about Earth's most ancient life forms. It will be interesting to see what we'll learn by more closely studying the minerals of Mars. So, to find out if there ever was life on Mars, you would look for traces of that life in a location where you know liquid water had been. Jezero Crater? Check. You would also look for minerals that are associated with life on Earth, because alien life forms might leave similar traces of themselves. But what exactly will NASA be looking for? If there ever was life on Mars, it existed a long time ago. Billions of years ago. So the idea that if there was life on Mars billions of years ago, it would have left traces of itself similar to the record left by some of Earth's earliest life forms, bacteria. Some of the oldest known types of living organisms on Earth are the cyanobacteria. These single-celled organisms changed our planet by pumping oxygen into the oceans and the atmosphere as they carried out the process of photosynthesis, and they have left biosignatures on Earth called stromatolites. These are sheet-like sedimentary rock formations created as layers of newer cyanobacteria grew on top of older layers of cells. NASA scientists have spent time in Western Australia studying stromatolites to learn how these rocks tell the story of organisms that lived billions of years ago. Mastcam-Z will take images that have a maximum size of 1600 by 1200 pixels with an image resolution of 150 microns per pixel to 7.4 millimeters per pixel. This, along with improved stereo capabilities when compared to Curiosity's Mastcam or the PanCams of Spirit and Opportunity, will allow scientists to have even greater detail when examining rocks on Mars. The video shows a panoramic view of Mars taken by the Mastcam component of Curiosity. Mastcam-Z will have the ability to provide even greater resolution of images. This information will be used to identify interesting-looking rocks that might bear similarities to fossilized stromatolites and other Earth rocks that preserve evidence of ancient life. These rocks will be drilled to take core samples, which will be cached and hopefully one day returned to Earth for future scientific analysis. Other features of Mastcam Z will be used to aid in navigation of the rover to avoid rough or dangerous terrain, imaging to learn more about surface phenomena like dust devils and cloud movement, solar filters to image the sun, bandpass filters to identify weathered rock surfaces to give information about important minerals such as silicates, oxides, and hydrated minerals, and finally analysis of wind transport of dust to determine potential impacts on future missions, including possible human exploration. Thank you for watching, everybody. Please keep checking back to my channel for additional videos about Perseverance and the Mars 2020 missions.